solution of first order linear differential equation class 12th. First form. Linear differential equation is dy by dx plus py equals to q. First order differential equation. First, once it is derivative and the degree of the dependent variable, here dependent variable is y, is 1, and p and q are constant or may be function of x. We solve the questions now. Exercise 9.6 NCERT class 12th. Question number 3. Question number 3 is find the solution of differential equation dy by dx plus y upon x equals to x square. The algorithm to solve the linear differential equation is first write the equation in the standard form and find the value of p and q. P is the coefficient of y and q is the terms in the right hand side. So here p equal to 1 by x and q is x square. The second step is find the integration factor. So integration factor is e to the power integration p dx so third step write this. So find the integration factor. So integration factor e to the power integration p is 1 by x dx. So integration factor e to the power integration of 1 by x dx is log x. So e to the power log x So integration factor is e to the power log x is x. Now step third, find the solution. Solution is y into integration factor equals to integration q into integration factor dx. So y into integration factor is x equals to integration q, our q is x square, into integration factor x dx. So y x equals to integration of x cube, x square into x is x cube. So integration of x cube, apply the power rule, x cube power 3 plus 1 upon 3 plus 1 means x cube power 4 upon 4 plus c. So the value of y is divided by x. So x to the power 3 upon 4 plus c x to the power minus 1. Answer. Okay. Next question number 4. Exercise 9.6. Question 4. Exercise 9.6. The question is dy by dx. Question is dy by dx plus sec x into y equals to 10x. X is greater than 0 and less than pi by 2, defined as x is greater than equals to 0 and less than pi by 2. So first step, convert the equation in the standard form, dy by dx plus py equals to q, and find value of p and q. So p is the coefficient of y is the our dependent variable. So solution p is sec x, coefficient of dependent variable y, and q is 10x. Now second step, find integration factor. Integration factor equals to e to the power p dx. P is sec x, so e to the power integration of sec x dx. So integration factor is integration of sec x is log of sec x plus 10x. So e to the power log of sec x plus 10x. So e and log cancel. So integration factor is sec x plus 10x. Now step third, find the solution. So solution of the equation is y into integration factor, that is sec x plus 10x, equals to integration q. Our q is 10x into integration factor, that is sec x plus 10x. dx. So y into sec x plus 10x equals to, now multiply 10x into the bracket, so integration of sec x 10x dx plus integration of tan square x dx. So y into sec x plus 10x equals to integration of sec x into 10x is sec x plus integration of tan square x. So write down tan square x sec square x minus 1. Now it is integrable. So y into sec x plus 10x equals to sec x plus integration of sec square x is 10x minus integration of 1 is x plus c. So this is the solution of the equation. Okay, thank you. Now next question, question number 5. Question number 5 of NCERT, exercise 9.6. Question 5, exercise 9.6. The question is, find the general solution of cos square x find the general solution of cos square x into dy by dx plus y equals to 10x. So our algorithm, first write down the equation in the standard form, dy by dx plus py equals to q, and find the value of p and q. So divide by cos square x both the sides, our first step. So dy by dx plus y upon cos square x equals to 10x upon cos square x. The coefficient of dy by dx must be 1, so that's why we divide by cos square x. So cos square x and cos square x cancel, and so our standard form of equation is dy by dx plus 1 upon cos square x is sec square x into y equals to 10x into sec square x. So our p is coefficient of y, sec square x. P is sec square x, and q is 10x into sec square x. So either you solve 10. So q is 10x into sec square x. 10x into sec square x. Now second step, find the integration factor. So integration factor equals to e to the power integration p dx, integration sec square x dx. So integration factor is integration of sec square x is 10x. So e to the power 10x. Now third step, write the solution. Solution is y into integration factor equals to integration q into integration factor dx. So solution is y into integration factor is e to the power 10x equals to integration q, our q is 10x sec square x, 10x into sec square x into integration factor e to the power 10x dx. Now again a question of integration in the right hand side. So it's a case of substitution. Substitute 10x equals to t. So put 10x equals to t. So differentiate both the side with respect to x. So sec square x dx equals to dt. So sec square x dx is dt. So now our question is y into e to the power t equals to integration 10x is t, sec square x dx is dt, and e to the power 10x, so e to the power t and dt. Now in the right hand side a question of integration. So it is integration by part. So by islet t is algebraic, so it is first function and e to the power t is second. So by integrating by part, y into e to the power t equals to, now integration by part, first function that is t into integration of second minus integral differentiation of first, that is t dt into integration of second, integration of second is e to the power t dt. So y into e to the power t equals to t. Now integration of e to the power t is e to the power t minus integration d dt of t is 1 into integration of e to the power t is e to the power t dt. So y into e to the power t equals to t into e to the power t minus integration of e to the power t is e to the power t plus c. divide both the side by e to the power t. So y equals to t minus 1 plus c into e to the power minus t. Put the value of t. So y equals to t is 10x. 10x minus 1 plus c into e to the power minus 10x. Answer. Okay. Now question number 6. Question number 6, exercise 9.6. Question number 6. Find the general solution. X into dy by dx plus 2y equals to x square log x. So first write in the standard form dy by dx plus py equals to q and find the value of p and q. So the coefficient of dy by dx must be 1. So divide the entire equation by x. So x upon x dy by dx plus 2 upon x y equals to x square upon x log x. So dy by dx plus 2 upon x into y equals to x log x. Now find the value of p and q. P is the coefficient of y, that is 2 upon x. So p is 2 by x, coefficient of dependent variable 2 upon x, and q is x log x. Q is x log x. Now find the next step is find the integration factor. So integration factor is e to the power p dx. So integration of 2 is constant 1 upon x dx. So integration factor is e to the power 2. Integration of dx by x is log x. So 2 into log x. So equals to, by property of log, it becomes e to the power log of x square. So finally our integration factor is, again use the property of log, e and log cancel, so e log x square is x square. Now the third step is find the solution. So solution, y into integration factor equals to integration of q into integration factor dx. So y into integration factor is x square equals to integration q. Our q is x log x. X log x into integration factor x square dx. So this becomes y into x square equals to integration log x into x to power 3 dx. So again a case of integration by part. So by islet, log is the first function and x to power 3 is second function, and integrate by part. So y into x square equals to, now integration by part, first function integration of second, that is x cube dx, minus integral differentiation of first, that is log x, into integration of second, x to power 3 dx whole dx. So y into x square equals to log x. Now integration of x power 3 is x power 4 upon 4 by power rule, minus integral ddx of log x is 1 upon x, into integration of x to the power 3 is x to the power 4 by 4 dx. So y into x square equals to x to the power 4 log x whole upon 4 minus, on solving this cancel, so x to the power 3 by 4, this x in the denominator cancel with this x to the power 4, so it is x to the power like this, x to the power 3 upon 4 dx. So it is x to the power 4 upon 4. So x to the power 4 upon 4, and 1 4 is already here, so x to the power 16 plus c. So divide, so y into x square equals to, take the LCM, LCM is 16, so this becomes 4 x to the power 4 log x minus x to the power 4 whole upon 16 plus c. So y equals to, now divide by x square, so x to the power 4 upon 16 and x square x to the power 4 common, x to the power 4 common, so 4 log x minus 1 upon 16 x square plus c upon x square. So y equals to x square upon 16 into 4 log x minus 1 plus c into x to the power minus 2 answer. Okay, thank you. Next question, question number 7. Exercise 9.6. Question number 7. Find the general solution. Find general solution of the differential equation x log x into dy by dx plus y equals to 2 upon x log x. So first convert the equation in the standard form, dy by dx plus py equals to q. So solution, coefficient of dy by dx is must be 1 and here is x log x, so divide the entire equation by x log x. So this we may write like this, dy by dx, divide by x log x, so x log x cancel, plus y upon x log x equals to 2 log x upon 1x is already, and divide by x log x, x log x. And now find the value of p and q. So p is the coefficient of dependent variable y, so p is 1 upon x log x, while q is log x cancel. Q is 2 upon x square. Now find the integration factor. So integration factor is e to the power p dx, integration of e to the power p dx, 1 upon x log x dx. So integration factor equals to, now integration of 1 upon x log x, again a case of substitution, very simple, put log x equals to t, log x equals to t, differentiate both the sides, so 1 upon x dx equals to dt. So here dx upon x becomes dt. So integration factor is e to the power dt by t, integration of dt by t. So integration factor is dt by t is log t, so e to the power log t. So integration factor is e and log cancel is t. Now put the value of t, so integration factor is t, log x, t is log x, so integration factor is log x. Now the third step, find the solution. So solution, y into integration factor equals to integration q, our q is 2 upon x square, q is 2 upon x square, and into integration factor, that is log x dx. Now again a case of integration by part. So y into log x equals 2. 2 is constant, taking outside. Now integration x to the power minus 2 log x dx. Integration by part. So I let log is first function and x to the power 2 algebraic is second. Apply integration by part. So y into log x equals to 2 first function log x integration of x to the power minus 2. So x to the power minus 2 plus 1 upon minus 2 plus 1. So it is minus 1 upon x minus integral differentiation of first. So ddx of log x is 1 upon x into integration of x to the power minus 2 is minus 1 upon x dx. So y log x equals to 2 into minus 1 upon x log x. Now minus minus plus, so 1 upon x square. So write like this, plus integration of 1 upon x square dx. So y log x equals to 2 into minus 1 upon x log x. Integration of 1 upon x square is minus 1 upon x plus c. Minus 1 upon, so 1 upon x common. So y into log x equals to 2 minus common and denominator say x common. So log x plus 1 plus c. Okay, thank you. This is the answer. Okay.